All right, so this is going to be question 1 from your review, as found on page 74. It's basically asking which functions are polynomial functions and to justify your answer. So that's what we're going to run through here. 1a, f of x, is describing what looks to be a polynomial function. You'll remember polynomial functions have to have no restrictions on their domain, and so they must be valid for all values of x. So I can input whatever I want in for x, and I will get a unique output for y. So in addition to, as we're going to see here, they need to be polynomials that maybe exceed that of a quadratic or x squared in order to fall into this kind of polynomial function category. So this one here is, and you'll notice I'm just using the function notation so you know which question I'm referencing. You'll see the function notation changes for question to question. So f of x is a polynomial function. And we'll do maybe back to back. We'll do like kind of 1i, and then subsequently we'll do part 2 of this as well. So it looks like I can see the leading coefficient of the polynomial is going to be 3. So the leading coefficient is going to be 3, and its degree is going to be 4. And I can see that from the leading term has a degree of 4. Okay, so we're just going to say it's quartic. Okay, so we'll just do this as we go down the page for each of these questions, and we'll talk through, and some of them might require a little bit of follow-up, but question B for this, g of x. G of x can be rewritten as 4x minus x squared, which then I could write in descending order, which would be negative x squared plus 4x. So back to my point earlier, this is a quadratic, which they're not classifying as a polynomial within the textbook, okay? So a polynomial function. And so we're going to say not a polynomial function. You'll see that the polynomial functions really kick in when we get to degree 3, okay? So this is a degree 2. The leading coefficient is going to be, we'll say LC, leading coefficient is going to be -1, and the degree is going to be 2, so quadratic. Okay, C, h of x. H of x can be simplified again as 3x plus 2x. Those are like terms, and so we're going to get 5x is going to be h of x in simplified terms. And so we're going to say this is also not a polynomial function. Okay, leading coefficient is going to be 5, and its degree is going to be 1, so it's linear. Okay, D m of x, again, we can write this as anytime you have a negative exponent like you do in D, you can rewrite that as 1 over x squared. So negative exponents can switch between the numerator and denominator, and their exponent becomes positive. So this is what we call a rational graph. Okay, and you'll notice there is a value of x here. Like let's say if I were to put in x equals 0, I would get a math error. Okay, so we cannot put that in, so that's a restriction. And we're going to say that x cannot equal 0 as a result. And that fundamentally breaks one of our polynomial function properties, where we say x can be a part of the real numbers, right? And so this is not a polynomial. Okay, and its leading coefficient is just going to be 1. Okay, E. Question E is r of x is going to equal 5x minus 1 cubed. Okay. So the degree here, this is going to be a polynomial function because we have a degree 3, so it's going to be a polynomial. Okay. The degree is going to be 3. Okay, and its leading coefficient is going to be 5. Okay, so this is what do we say? A cubic. Okay. And that's it. So that's page 74, number 1. Just talking about classifying something, whether or not something, a function is going to be a polynomial function or a different kind of function.